Hi, everyone. Very happy to be running this live cast public event in parallel to our SCARES conference. Just for context, this is a conference we're organizing at the moment at CERN in Geneva, focused on the environmental impact of computing and how to make these impacts smaller. In parallel to that, we were very keen to organize a public event, so streamed on YouTube, where we are now, where we bring some of the absolutely brilliant speakers we have throughout the conference on a panel to talk about this topic from a slightly different perspective. So I'll give a quick introduction, just as a background, so everyone starts with the same kind of base knowledge, and then we'll dive in straight into question. The main thing is the link at the bottom left of all the slides is a QR code to a Slido, and you can just use that to ask any question you want, and that's how we're gonna ask questions to the panel. You can also vote on your favorite questions, which is a great way to make sure we take the most popular questions first. So let's start. This slide is just to highlight, there's no doubt that high performance computing has enabled absolutely amazing discoveries, especially in recent years. For the topic of today, it's particularly interesting that it has also enabled discoveries in the fight against climate change. We can think about optimizing energy grids or supporting biodiversity. And so this is really, really key applications. But what we're also interested in is that it comes at a cost. The link between these two slides may not be immediately obvious between these two pictures, but actually, globally, data centers have about the same carbon footprint as the entire American aviation. So although they are two different sectors, it is hard to completely dismiss the carbon footprint of data centers. And with the growth of AI and generative AI in particular, we don't see this impact decreasing anytime soon. Let's take a few examples. Most countries' data centers use maybe 2, 3, 4% of the energy grid. So there is sometimes a tendency to think this is not that much. But let's look at Ireland. In Ireland, data center consume 22% of the energy grid. For comparison, all the urban dwellings, so all the private homes in cities, consume 18% of the energy grid. So that's more than everyone living in cities. And that is actually something to be mindful of. It means at some point, data centers start competing for resources and power in particular with private homes. So what happens when we hit the limit? It's really hard to build new data centers in Ireland because there's just not enough power to power them. And what we've seen in recent weeks is that when push comes to shove, new data centers have to be built off grid. So they are not connected to the main power grid, but they need their power. In the case of the recent one in Dublin, it turns out to be natural gas. So much higher environmental impact than renewable energy. And that is something we have to be mindful of, is that if that becomes a trend, we will see more and more data centers coming with high carbon power generation. I also like this number, 45%. That's what the trade body for the telecommunications sector said. We need to decrease the carbon footprint of the digital sector by 45% by 2030 to stay on track with the Paris Agreement. And that is interesting because it's a trade body not saying we need to do 45% more with the same energy. We need to reduce this carbon footprint by 45%, which is quite significant. And we will try not to throw too many numbers as tons of CO2 and things like that around, but we probably will throw a few of them. And so in this context, it's always useful to put it in context. One way to put it in context is to think about the number 2. 2 tons of CO2 per year per person. That's the target that the IPCC has set up to stay on track with to keep global warming under 1.5 degrees. We're going to talk more about AI, but because it always comes up, I thought I'd throw an example. There's the main problem with AI is a lack of transparency about the environmental impact of training and using generative AI models like ChatGPT or Copilot or Claude. But a French company did an assessment of their own large language model, so-called Large 2, and although the study comes with limitations, they found interesting results. So over the year and a half it took to actually train the model, including research and development, they found that training the model emitted 20,000 tons of CO2. Comparing to the yearly allocation we mentioned just before, that's the yearly allocation of 10,000 people. It also came with almost 300,000 cubic meter of water, and the last metric refers to extraction of raw materials. So quite a large impact. And that's a quote I like in this context. For the life of me, I really can't find who said that first. It's not me. And it's saying that data centers is where the cloud touches the ground, because there can be a tendency sometimes to think of data center as this very immaterial component, but it is not. They are servers and data center, the cloud. So, the cloud has real physicality. There's a lot of hardware and power that underpins this texture. Actually, the cloud is a terrible name for it, but that's what we've got. And so computing is not free. Sometimes it looks like it. And when we use ChatGPT for free, for example, or even researchers, when we use some of the models because we have access to some scientific computing clusters, we don't really think about this cost, but there is a cost. And sometimes there's a bit of a negative feedback loop here. So I'm based in the Department of Public Health at the University of Cambridge. And a lot of my colleagues work on the on the health impact of climate change using AI and using computing models. And so you feel, well, are we just making the problem worse? And so that's a genuine question. And that's something we need to keep in mind while we work on these topics. So before we dive in, and because we'll talk a lot about computers and cloud and things like that, I thought I would actually give a quick background. So you may hear some of us sometimes talking about HPC for high performance computing, but the same principles applies to the cloud. So that's a not very modern computer, but I needed the picture. You'll see why in a minute. But really, a computer like that, it has input, that's your keyboard and your mouse, and it has all the processing unit, that's kind of the brain. So that's the computing tower. And then you've got the output, which is the screen where you see it. Obviously, in your laptop, everything is integrated. But you don't actually need to have everything next to each other, to one another. If you're interested in that, you can relocate the compute in a different room if you have a long enough cable. And that would still work exactly the same way. But obviously, we've got better than a cable, we've got the internet. And it would be a bit silly to have just this one desktop computer in the center of a room. So instead, we put a lot of them next to each other and a lot of people can use it. That's all there is really to high performance computing and data centers. That's a data center, and it means we can share resources and just borrow some resources when we use it. When you use the cloud, that's exactly what's happening. Now, thinking about environmental impact. One reason it may seem overwhelming sometimes is there are lots of different angles to this question. We can think about what we call embodied footprint of hardware, and that's the cost of manufacturing it, extracting the raw material, building the hardware, or the operational footprint, which is the cost of running it, mostly through power generation. We talk a lot about carbon footprints and greenhouse gas emissions, and that's what I've done so far. But this is not the only environmental impact to consider. We may want to think about water. We may want to think about biodiversity. And finally, it's all good to think about computing, but sometimes we also need to think about data storage. And so I'm not going to go into great details into all of these, obviously, but I just wanted to spotlight some examples. So this is a picture of Baotou in Mongolia, where you can find the Baogang steel and rare earth complex. This is a complex of factories that are absolutely essential to the manufacturing of any digital hardware in the world. The artificial lake you can see is actually the output of all these factories who have production waste and have created this artificial lake, which probably is not a great idea to swim in. And that is really this kind of impact that we need to be mindful of. So we can't just think about energy usage. The World Health Organization has also a rather depressing report at the other end of the spectrum of what happens to electronic waste or e-waste. And they found that over 80% of the electronic waste ends up in dump sites. They estimate about 50 million tons of electronic waste. There are millions of people, up to 50 million, according to the WHO, working in informal waste processing, and so that's something we need to be acutely aware of. So as I said, not all about carbon. And one way to think about it, and we don't have time to just expand on this concept of planetary boundary, but I just wanted to plug it because it's a really useful framework. And if you're interested, you can just Google it. But these planetary boundaries are 9 processes that together maintain a stable and resilient Earth system. Let's make sure things don't get out of control. And really, if we want to keep things under control, each of these boundaries needs to stay in the green area. As of 2025, we've crossed 7 of these 9 boundaries. And this is particularly worrying when we think that these boundaries are quantitative assessment of the safe limits for human pressure on these boundaries. So climate change and greenhouse gas emission is one of them, but it's not the only one. You can see things like ocean acidification or land use, and so that's a useful framework. But I'll just leave it there, and we'll focus back on computing. So if we focus back on computing, we can think that there's the operational footprint, so the carbon footprint of running things, and that's probably what you were thinking about getting here. And that's a ratio between how much, well, we need to figure out how much energy we need, and that mostly depends on what we're doing. What is the hardware, and what task are we doing on this hardware? And then we need to figure out the carbon footprint of producing that much electricity. And that mostly depends on where we are in the world. Most data centers are plugged to the main power grid, except the Irish one I mentioned at the start. And so if we want to so this thing called carbon intensity is really interesting because obviously it impacts all aspects of our lives. So there's a website, for example, really interesting called Electricity Map. You can check out your country and you can zoom in and see the carbon footprint of electricity usage at different times of days. And you can see great variability on that. So for example, let's say we want to relocate our data center from Sweden to Poland. Same hardware, same types, same everything. We multiply our carbon footprint by 28. Now that's a bit extreme as a move. Let's stay in the US. So we're now on the northwest coast in Washington State, and we just change county. So we move a little bit, different energy providers, and the energy grid on average will be 9 times more carbon intensive. Right, that's enormous. You almost multiply your carbon footprint by 10 just by relocating slightly due to difference in energy generation. And so that shows that greening the energy grid is one of the powerful impact on this kind of impact. Now, that's not the only solution, and I'll stop on that. We can think about energy efficiency. We can think about using less energy. But then we get hit by this nasty thing called rebound effect, or if we want to be fancy, we can call that Jevons paradox. And that's this idea that if we make something more energy efficient, people use it more. So for example, making cars more energy efficient doesn't decrease the number of cars on the road or reduces fuel consumption. It just means there are more cars on the road. You make a motorway twice as large to avoid traffic jam, you don't really reduce traffic jam. You just have twice as many cars on the road. And that led to this paradox in the computing world, which is for years, computing hardware, CPUs, GPUs, processors, are more energy efficient every single year. Data centers are more energy efficient every single year. And yet the energy usage and carbon footprint of the sector increases every single year. And so that shows that we can't just make things more efficient. We need to think differently about how we use these resources. In the case of research, researchers on the ground have to think differently about how they use computers. More broadly, we have to reconsider how, for example, AI or other tools are being used so that they are used when there is value, but not wasted. And that takes me to my last slide, where I can just leave it there. And we will introduce our wonderful panel. So I realized I didn't introduce myself. Maybe I should have done that first. But I'm Loïc Lenlong. I'm a researcher at the University of Cambridge working on sustainable computing. And I will be hosting this panel tonight, and very excited about that. So let's start with Jyoti Bogar, who is an independent researcher and a fellow of the Software Sustainability Institute, and will tell you a bit more about how she comes to this topic. Thanks. And I'll stop sharing my slides. Thanks.
Hi, Loïc. Thanks for introducing me, and thanks for giving us the introduction to green computing and its importance. Thank you, Loïc, all the organizers of SC for RC, and also Pete for running this public webinar. My name is Jyoti. I'm a trained statistician, a community builder, and a research software engineering advocate with a foundation in data and open science. My training in statistics created my groundwork for career in research and software. And this curiosity led me to open source tools within the R software community and eventually into the global RSC movements. What brings me to the green computing community is that as a software developer, I have always been keen on creating or developing software which does not have a bad impact on the environment. That's my curiosity, and that brings me here. Thank you, Loïc.
Brilliant. Thank you so much. Our next panelist is Laurent Fréau, who is visiting us as a postdoctoral researcher from the University of Vienna.
Hi, everyone. Hi, Loïc. Thank you for the introduction. My name is Laurent Fréau. I'm indeed a postdoctoral researcher at the University of Vienna. I'm working for the Wide Field Spectroscopic Telescope Consortium, which is an EU-funded project. And the idea is to develop a telescope project which could be built in Chile in the 2040s. And so now with the telescope, we collect a lot of information, a lot of data continuously every night for a long period of time, ideally decades, depending on the lifetime of the facility. And of course, this data needs to be processed, it needs to be calibrated, it needs to be stored somewhere. And when we are talking about a project that could be built in 2040s and could start collecting data in 2050s, in my opinion, we need to start thinking about green computing, and we need to take this environmental impact into account as early as possible, because given how the climate crisis is evolving right now, it's also a responsibility as scientists. And I'm also steering group member of Astronomers for Planet Earth, which is a grassroots movement of more than 2,300 astronomers or people related to astronomy. We have also students, we have people in outreach. And what we try to do is to bring the unique perspective that astronomy has on the climate crisis, and in particular, the fact that we know that there is no planet B. But personally, I find this green computing topic very fascinating. And also from an individual perspective, it's really interesting to try to understand how will the landscape look like in 2050s and what we can do already now to try to reduce it. So very happy to be part of the panel.
Thank you so much. Such a fascinating angle on this. Thank you. So our next speaker is Raghav Selvan, who is an assistant professor in the Department of Computer Science at the University of Copenhagen.
So hi, thank you, Loïc, again, and then hello to everyone. So as Loïc said, so I'm Raghavendra Selvan, but the popular version of my name is Raghav. I'm an assistant professor at the University of Copenhagen. On a daily basis, I do machine learning research, so AKA related to AI. So I'm here to take the blame for our entire community. So that's the short of it. But I have, on a daily basis, like I said, I do machine learning research, but at the intersection of ML and sustainability. So this goes both ways. One is using machine learning methods for sustainability applications. But also we've been interested in the question of the sustainability of AI and ML methods itself for about 6 years now. And I was asked to kind of reflect a little bit about why, I started asking these questions. And I have like a little bit of a slightly different story because it sort of stemmed out of necessity. So around 2019, when we as researchers were trying to, reproduce results and do publications and check what other companies were doing, etc., we were unable to run those jobs simply because, the amount of compute that started going into these large-scale machine learning models started growing about, 2017, 2018. If you know the literature, that's when the transformer, paper happened. So this sort of led us, me and my team, into starting to think about, okay, we need to bring in resource awareness into these questions instead of just saying that because I have a big data center, I can build a model. And this started increasingly becoming more and more important. And the way we tried to, normalize for this was to look at the energy consumption and the carbon footprint of computing jobs. And this led us into building one of the tools that is still being used. It's called as Carbon Tracker. So you can try it out. It's a Python tool, and you can install it and then try and measure your own compute jobs. And that was sort of the entry point. And then since then, we've been looking at different types of questions pertaining to AI and sustainability. So as I said, because of my machine learning research focus, I do a lot of algorithmic work, but I also collaborate with a lot of social scientists and ethicists because I cannot solve this problem hacking away at my keyboard. So yeah, that's me.
Great. Thank you so much. And last but not least, Kirsty Pringle, who is a project manager at the Software Sustainability Institute.
Hi, great to be here. Yes, so I'm based at the University of Edinburgh. I work for the Software Sustainability Institute. And for about the first half of my career, I was a climate scientist. So I was using these big models, running on these HPC systems to try and better understand climate and understand the effect of human activity on climate change and on air pollution. And I think that was super interesting and really important work. But after some time of doing this, I kind of became aware of the environmental impact of the computing itself. And that led me to kind of not so much question the importance of the research, because the research is super duper important, but it led me to kind of think about how we as a community are doing the research and whether there's something about whether we can change how we approach this research, whether we're using the resources as efficiently as possible, basically. So I now work for the Software Sustainability Institute, which is a UK-based organisation. We do a lot of community building. And communities are a really interesting approach to solving problems, because I think one thing that will probably become clear today is that this is a really complex problem. We want to be able to do great science, but we want to do it in the most environmentally sustainable way. And I think in order to solve this, we need to get people together, we need to build communities and really bring people together to discuss this. So less of a technical background and more of a kind of trying to understand how we can make sure that people are talking about this and people are discussing this. So it's great to see this webinar happening.
Great. Thank you so much. So I think now we will all show big on the screen, and we'll start with some of the questions. Actually, just before we jump in, we as part of the advertisement for this event, there was a poll linked to the social media post asking people, if you had to guess, what would you estimate the annual emissions from your personal computing use to be in CO2 equivalent? So CO2 equivalent is a standardized metric we use to estimate the greenhouse gas emissions. And the two most popular answers were either between 100 grams and 1 kilograms of CO2, and the second most popular answer was between 10 and 100 kilograms of CO2. I have to say, I wouldn't know how to answer that question if I had to, because I think I could do some of it, but we still lack transparency with AI. So I'm not going to make the panel vote, but if you want to jump in with your first answer later, feel free to chip in. Let's dive into the Slido's questions. Feel free to add more questions to the Slido's or upvote the one you prefer. And I think with the first one, I'll go to you, Raghav, first. I mean, especially because you didn't promote it, but you have a book out recently, Sustainable AI, which is an absolutely brilliant book. I've been using the excuse of having time in transport for this. So it's actually in my backpack for this whole trip, and it's a really interesting book. Kind of introducing the basics of machine learning. So I was kind of glad I trained as an AI person, so I was glad to brush up on some of that. But also explaining what we can do about it. So if anyone is interested in AI, do check it out. But so the penalty for that is to have to answer the first question first. Are we undercounting AI's real footprint? Should there be a standardized cradle to grave accounting framework before further scaling? And maybe if you start by just explaining quickly what cradle to grave would mean. Thanks.
Mm-hmm. Yes, so I think certainly we are undercounting the real footprint, but even before getting to the cradle to grave, I would like to kind of decouple this into two aspects. So one is the materiality of the infrastructure that we now should be seeing it as AI, because I think generally we think of AI as some sort of hive of algorithms, but as Loic very nicely pointed it out, it is these industrial warehouses where really powerful computing machines are churning away. So and the cradle to grave question there is also what Loic pointed out when we start manufacturing the hardware. So we are starting out by extraction of rare earth minerals or mining and refining silicon chips and fabricating them, putting that electronics together, building a data center, and then construction industry is also one of the most carbon intensive ones out there. And just as a side note, in 2025, globally, the largest investment that went on was in building new data centers. So meaning there's also a lot of, construction related work that is happening there. And then once we start using these computers, there's also this other statistic that a data center has an average refresh rate of about 5 years, which means everything within the data center, including the chassis and then all of the components, have to be replaced. And this is more so for machine learning models because the hardware, because of efficiency gains, keep getting better. So you have to keep replacing all of the electronics. And then once you have to pull them out, what do you do with them? And this is the e-waste and the grave situation. So what we can do, for instance, in the tool that I presented or I mentioned, Carbon Tracker, we only look at the operational carbon emissions of the job that is running on your computer or on some hardware. We don't take any other aspects into account. So you should treat that as a proxy to the broader, costs that are going on. And because currently all of the discussions about AI are based on back of the envelope calculations, because we don't know how many data centers there are actually, how many AI data centers there are, who's running what. So this information is actually not known. Even if you were to, look at your own computer saying like, okay, let me just I have a GPU sitting at my desktop. Let me just make that estimation. Even then not, because the individual hardware components, we don't have, transparent information about the embodied emissions that Loic mentioned, all of the other broader environmental impacts. These are all, unknown. So as a result, I think we are extremely, undercounting AI's environmental impact. Now, there is this other nuance, which I also would like to bring in as a sort of a computer scientist, that even within the algorithmic life cycle, I think we are not looking at the entire life cycle. So we are usually talking about the training life cycle, training of the models, or the usage. Loic again pointed out that there's the computing and the storage part of it. So AI models are trained currently on what we call internet scale data sets, which is, you scrape everything that there is on the internet and then you put it on a disk and then you let these models digest them. So that has a lot of cost. And there's another aspect, which is like what we call model selection. Before I train my model, I have to try out very many configurations of these models. So that incurs additional cost. So we are not taking any of that into account. So to answer the first part then, certainly we are undercounting. Should there be a standardized cradle to grave accounting framework? I would say yes, but it has like several problems, which I think we will get into. Again, one of the things is technically it is currently not. I don't see that, we have the tools right now, even if there were a framework like this to put things in place. So meaning there's a lot of work that needs to be done even at that front. Yeah.
Thank you. That's very clear. And actually, you're right. There are so many different facets to it, but it is worth keeping in mind. I always think it shouldn't be overwhelming, the different facets. We need to keep in mind that it's complicated, but it doesn't mean we can't tackle these different components separately. But no, that's really good. All right, maybe moving slightly away just from the AI. I'll try not to do a full AI blast because I assume a lot of the questions will be about it. We'll go with the next one. I guess maybe actually if everyone can quickly answer that one. As researchers, considering the environmental sustainability of scientific computing, are you in the minority or is there broad acceptance that this is important? Let's go maybe Laurent first.
That's a very good question. I think that at least in my research community, which is astrophysics, we are still a minority, but it's a growing minority. So this is very encouraging. And I see that a lot of people are actually not really aware of the problem because, as you said, Loic, also in the introduction, computing looks free for us as researchers. We just plug in jobs so we don't really see the impact on the environment. But I also see that by starting discussions around lunch or over coffee, there is a lot of growing awareness, and also people want to understand a bit better all this. So it's quite encouraging, I would say.
That's interesting. Thanks. Jyoti?
Yeah, so quite like what Lauren said, I think there is a broad acceptance or awareness of the fact that scientific computing needs to be more environmentally sustainable. I hear people speaking of how often or how less often they replace their laptops, or how they are reusing, like for example, how they replace only parts of their compute machines when needed. So there are these little acts which show how there is an awareness in the research community. When it comes to policy, I think there can be more work done so that using green computing practices becomes a norm in research groups and in computing groups. Yeah, that's about it.
Great, thanks. Raghav?
Yes, I think here, because the scientific community I most work with is the machine learning one. And I think there is an increasing minority of people who are starting to pay attention to these costs, like Lauren also mentioned. That is simply because that is in some sense thanks to generative AI, because there's been so much of uptake of this technology. And I think that immediately has these costs, and people have started discussing. And I think there is some of our conferences, for instance, are making it mandatory to report the amount of compute we use on tasks and things like that. But it is encouraging. Yeah.
Thanks. Maybe I'll talk about mine and then kick it off to Kirsty as our community expert in residence. So my background is health data science, so kind of health research. And actually, I like your increasing minority way to phrase it. I think that's the right way to put it. Health research, maybe because working on health impact of climate change has actually picked up this environmental impact quite well, but it is still a minority if I had to pick one. But yeah, I agree, increasing share. Kirsty?
Yeah, I agree. It is increasing. It's late. It's kind of slow for them to be on board, but we're getting there. In general, I think that people are very interested. So it's people working this topic, and they're very knowledgeable, but for just your average researcher, it's not always clear what the right thing to do is. And it takes quite a lot of work to understand what tools there are out there, what frameworks that they could use to assess. So it feels like a big extra job. So you have a few people that are real pioneers in this area, and they're doing a lot of work, and kind of doing the headway in terms of making sure this is understandable and clear for others. But then there's kind of this lag as the other people are a bit less engaged, but a little bit interested, are beginning to adopt these practices and these tools as well. But there's a real delay in terms, and it's just bandwidth. People are very busy. People have got important research to do. So if we can try and make sure that it's prioritized so that people have some time to look into this and make it easy for them to adopt environmental practice, sustainable practices, then that's a great win, because we save researchers time, we get to do more research, but we also get to reduce the environmental impact.
Yeah, that's really good. Lauren?
Yeah, I just want to follow back also on this. So I think it's a very uncomfortable question also sometimes to ask, because I think about astrophysics, and part of people, colleagues, they work on huge simulations, and we're talking about simulating how the universe is evolving. So it's requiring, I don't have the numbers, but it's really something crazy. And then when you're talking to them about, okay, have you ever considered trying to quantify the environmental impact of this? You see that it's a bit uncomfortable, because we're really talking about their day-to-day research and their work. So this might be also a problem to face.
I'll come back to you, Lauren, with a question in a minute, just on this point. But no, I think that your point, Kirsty, about being late is so important. Like, if we think about so moving away from just data centers, but thinking about how we do research, so more on the kind of scientific computing side. Other areas of research have been thinking about the environmental impact for a long time. If you look at like wet labs, so experimental labs, people with like lots of equipment and chemicals and things like that, because they see the single-use plastic they use all the time, they see the big machinery. It's been a long time since they had like very extensive initiatives to try to reduce this environmental impact. You know, with more or less success, they encounter the same issues we do, but it's really taken a long time for scientific computing. I think Raghav was mentioning 2019. That's really when it started, and then there's been this boost in the past few years because of generative AI. So we are kind of late to the party. So we need to work double hard to catch up. Right. So interesting question is, how do you decide when the scientific benefits of large-scale computing outweighs its environmental cost? And I'm going to go to you, Lauren, because I think that's an interesting question in the context of, you know, the large project you're working on.
Yeah, that's such a good question, and I think the clear answer is that you don't actually. It's very hard to do in the design phase of a project, because we are passionate about what we're doing, right? So we really believe in the infrastructure that we are working on, and on why we are using computers and supercomputers in general. So it's a very complicated question to answer. I would say the only thing that I see is, once a project is done and constructed, in the years that will follow, then you can assess now who is using it. Are enough people using this facility or this large computing data center, for instance, that is justifying to build it? And what do we give back to both society and maybe economy also, while minimizing the impact on the environment? So I would say it's only once this is done. But of course, we need to consider it during the design phase also. This type of reflection, this type of question are really important to discuss together. Yeah.
That's interesting. Jyoti, go ahead.
Yeah, just to add to that, I'd like to say that in order to find the balance, we need to think about about both the embodied cost as well as the operational costs, and also take in consideration Givon's paradox, which is the rebound effect of having more efficient computing material. So I think the solution here would be to work at multiple levels. Technically, we should encourage the use of more efficient software algorithms, reproducible workflows. And on the other hand, we should also, at an institution or a funder or journal level, we should think about treating computing resources as something that needs justification and transparency, similar to financial budgets for other approvals.
Thanks. No, that's a really interesting idea. Raghav.
So I think I want to make like two small points. One is that at least this is how we conduct our research in the sense that any technology, should not be decoupled from its material resources associated with. I think that is sort of the fundamental premise with which, we try to operate, which means then you start measuring and the reporting. And I think with that, we start maybe getting a little bit of awareness about it. And that I think should be the first step. So irrespective of what we try to do, we should start, measuring and then reporting. That would be one. And then what this leads us to is trying to then work out trade-offs. So because everything, you can have a trade-off between, for instance, with machine learning models, you can make them slightly more efficient if you are okay to live with a small drop in performance. So meaning until we don't have this two-axis, so this multi-axis view on stuff, it will, I think that would be the way to do this in a responsible manner. That would be my my take on this question. Mm-hmm.
No, that's a really interesting one, and that's such an important question. I'm sure everyone here, it keeps coming up every time we talk about this topic. Is how do we balance it? No, that's a really interesting one. There's so many good questions. I'm just looking at the questions at the same time. They're all really good and they're all really hard. So I'm kind of glad I'm not the one who has to answer them first. I guess maybe just on what we talked about, because we talked about quantification just now. What are the main approaches to minimizing the environmental impacts of large computing? Is it only monitoring, quantifying, and reducing usage? Kirsty, do you want to take that one?
Thanks. It's a tricky one. I mean, there's a lot of really interesting work going on in this area, and I think if we're talking about HPCs or services that we run as a community, then to an extent that is easier because we have access to all the data. It gets much harder when you're outsourcing, when you're running your model simulations on kind of commercially available cloud, because there's a lot of work in terms of facilities which are run for researchers, kind of by research organizations, research institutions, and they're doing some really interesting work about monitoring and reporting, and even looking into whether reporting changes user behavior. So you kind of look at this kind of rebound effect to see whether having this additional information is actually making a difference into how people run their jobs. There's a lot of technical support which can be really helpful. So just because you're a researcher that uses software doesn't mean that you're an expert in software engineering. So sometimes you can have a software engineer come in and say, that code's fine, scientifically, it's absolutely fine, but I could make it more efficient. And that's a really interesting role and a really important one in terms of having people that are software experts and really specializing in understanding energies and things like that go in and do that. One of the, I think, the huge challenge is the fact that if you then take your code and you run it on a commercial cloud provider, the amount of data you get back in terms of the environmental impact of that is tricky to get those numbers out, and you need to really know to understand and to challenge those numbers. And often numbers are, it would be lovely if there was a really nice simple answer, but often there's a more complicated answer behind the simple answer. So we need experts that can really dig in and try and understand what those environmental impacts are, what those numbers are. And I think that's a bit of a gap at the moment. I'd really like to see that taken more seriously.
Thanks. That's a really good answer to what is a very difficult question. But I think your point about data transparency is so important because, like, the goal is not to calculate, and I say that as someone who builds carbon calculators as well. It's just a tool to understand how can we reduce these impacts. But we do need this data. It's a really important, really essential step. And it's fine, as you said, when we work with our own servers. The moment you go to cloud providers or you use private AI models, you use ChatGPT, you use Claude, you don't have this data. But I think it's not only that, it's data that's complicated to obtain. It's a very deliberate effort by these companies to make sure we cannot possibly find this data because they have it, they could make it available easily. There would be some uncertainty, I get that, but it could be made available. And so that's something we really need, and we can't really do it. It needs policy, but that's a real problem. Is we kind of blocked at the first step by these companies who just refuse to release the data. Kirsty.
So just as a little point, if you look at other industries, like, so there's a lot, I work a lot in air pollution. So the car industry have famously underreported emissions and they got into trouble for it. If you look at other industries that have been asked to self-report environmental data, there's a long history of, deliberately making it difficult to get the data, deliberately making the data hard to interpret, sometimes even misrepresenting known environmental impacts. So I think we should definitely look at other communities and look at, it's clear that it's not the case that we can necessarily trust providers to give, given other experiences with other industries. So I think we need to be a little bit canny about that, a little bit aware.
Yeah. No, that's really interesting. I think I agree. We can learn a lot from other industry, despite all these claims that, oh, it's a completely different world and nothing can be compared to before. We can still learn about it. No, thank you. Someone very kindly in the chat, in the sliders, has been sending an easier question. So maybe I'll just put that one in now before we dive back in. An easier question. When and why did you start thinking about sustainability in computing? So I think it's interesting if we just go around the room again. I can start actually around late 2019, early 2020, when there was this first couple of papers about carbon footprint of machine learning. I was in bioinformatics and we were like, what about bioinformatics? And it turns out there was a zero paper in this space. So we decided to get started on that. And that's how I got started. I'll just go around the screen. Raghav?
I think I already mentioned this in my introduction. So it was around 2019, and then we started asking. It was mostly from the question of democratization of this very expensive technology, and then I think a very useful lens then was to use sustainability and then look at it from environmental sustainability, social sustainability, and economic sustainability. And I think that's how we got into addressing this a little more comprehensively, I think. So yeah.
Thanks. Laurent?
I think for me, it was more recently, I would say maybe 1 year ago or /6 months ago, because through the telescope project I'm working on, we are trying to look at several aspects of the telescope that could be made more sustainable. So yeah, computing and data storage, data transfer, everything linked to data generation in general is one aspect of it. I find it so fascinating, but it's also very overwhelming because there is so much now more and more information on this, but yet not a lot of clear direction where to go.
Interesting. Jyoti?
Yeah. So for me, this would go back to my college days during my bachelor's degree. So when I was using a laptop with a very small compute power, and I needed to find out how should I write a program so that I can do it efficiently on my little laptop. So that was my first introduction to green computing. And then lately with the boom in generative AI and how people have actually started using Gen AI as a substitute to Google search engine or other search engines, that made me felt really scared about the environmental impact of using such huge computing algorithms that go behind LLMs, which we cannot see with our eyes. So that was my, that is when I got more interested in the impact of computing on environment.
Thanks. Really interesting. Kirsty?
So I'm such a geek. From a very early age, I wanted to be an environmental scientist. So it was quite niche. And so I kind of grew up with this interest in the environment and wanting to, in some way, to make a difference. And I always thought that would be a really nice impact, to have for your career, that you feel in some way you've improved the environment. But it was more of a pathway of going from climate research into understanding the environmental impact of computing. I mean, environmental science, every single industry has environmental impacts. You rely on so many industries, and quality of life is improved by those industries. But I'm quite interested. I think you can dig into any industry and find it interesting how you could reduce the environmental impact of it. It's just that I like the research environment, and I'm really passionate. The research is important, that we should keep doing really good and exciting research, but I want to make sure that the two interests don't cancel each other out.
I'm actually so glad this question came up. Jyoti, go on.
Yeah, so just to add a fun fact over there, I like crocheting, and I was aware of the concept of temperature blanket. And a few years earlier, interestingly, I had started seeing Kirsty's post on LinkedIn, where she and some people from her group at University of Edinburgh and other institutes started displaying, visually displaying the impact of compute on environment. So that visual description was something that really got me interested. Yeah, thanks.
Excellent. Well, that's why I'm so glad this question came in, because it just shows like there's so many ways to get interested in this topic. Like you don't need to come at it as a computer scientist and do the traditional route. Like everyone comes at it a different way. So I hope, if we can kind of motivate some people to get involved in that, regardless of their field or what they're interested in or their angle or their research or their industry. I think that'd be a very successful panel. No, that's really interesting. Right. I think, Raghav, I'll go back to you. There's this question, what can I do day to day to reduce the impact of my personal compute use? And I'll maybe just tweak it slightly for the kind of AI side, because I think that's one of the things people are very interested in.
Yeah, so I think there's like some specific things that we can use. Like this, I already touched upon early on the trade-offs. So when do I need, if we know that this is an expensive, tool, then when do I really use it? So knowing that cost and then taking that into account when we use it is I think, a first good step. And I mean, there are some more nitty-gritty technicalities. People talk about using smaller prompts and then asking for smaller responses and things. So these are all okay. But I usually end this by saying that we can all do a lot of individual changes. But I think we should resist the individualization of responsibility when it comes to the climate impact and the environmental impact of these technologies, because there are only a handful of corporations right now who are building these tools at using a lot of public commons in terms of the energy and then the carbon footprint. So I think what we can as individuals still do is mount pressure at every level. So for reporting, for regulations, and for doing better and collaboration, so that we don't waste effort. So I think having this in mind, and then while we also do small little actions ourselves, I think mounting this pressure at the community level, maybe Kirsty will have more to say on that. I would say that is what I would encourage people to do. So.
Anyone else has like practical action they tend to recommend people in that? Yeah, Jyoti, did you want to jump in? Too late. You're unmuted. You have to go in.
I'll let Kirsty also. Okay, so just few examples would be shutting off our laptops daily instead of putting it in a sleep or hibernating mode. These are things that people can do on a day-to-day basis. Also, there are some browsers that can be used. I'm not marketing for it, but there are browsers like Ecosia. When you use those as a result of searches, they tend to plant trees in proportion to how many searches have happened. So these are a few tips that one can use to reduce their day-to-day impact.
Kirsty, did you want to jump in? Oh.
It's what you get for not raising your hand properly, sorry. My little kind of addition would be just to keep devices for as long as possible. Like if your mobile phone, if you can not replace it as regularly, then it will have a huge impact on the environment. I totally agree about using your voice as well. It's very easy to get disheartened and feel that your voice counts for nothing. But the more of us that stand up and speak and ask those questions and use our purchasing power, email the companies, ask them what environmental about. The more of us that do that, obviously one voice doesn't make a difference, but everybody together, it starts to really make a difference.
Yeah, that's so important. Loan.
Yes, I mean, I agree with everything that has been said before. I just wanted to add on a fun fact because I see that a lot in my close circle and family, and they are using ChatGPT or any like generative AI for everything. Like they have a small problem for health or something, they will ask first. That's now the the direct reflex that they go to. So just an easy maybe advice: don't do that. If you have a problem, call a doctor, or just if you want a recipe of pasta, you can Google it like all the time now. We would say. So yes, that would be my advice.
I'm not sure I would cook pasta recommended by ChatGPT. I'd be a bit scared of health impacts of that. No, all excellent point. Thank you so much for sharing all of that. I think we'll tackle the last two questions. One, actually, maybe the first answer, I'll send it to you, Jyoti. I'd be interested of it as a researcher based in India. Are you concerned about neocolonialism in the placement of data centers and their resource use, and inequalities in their impact on local populations?
Well, that is honestly one of the most tricky questions on the panel. And in order to answer that question, I was actually looking up the number of data centers across the world. And turns out that the maximum number of data centers are in US, UK, and some parts of Europe. What I have observed is that there are quite a lot of centers to process the e-waste across the global south countries. But I'm not really sure if that is fully true. So yeah, I do feel there is a bit of neocolonialism in there, but I think that will need more research. Yeah.
I mean, the lack of data. No, thank you for taking this one. It is definitely a tough one. But yes, I mean, electronic waste tends to be disproportionately shipped to countries in the global south with very little regard for the impact on local population. And I think that's one of the big problems, is this idea that when we think of cost benefit, we've talked a bit about that at the start, like how do we balance the cost and benefit of using computing? We tend to think at a global level. Like on average for the world, the benefits will be X and the cost will be Y, but this is not evenly distributed. If we build a new AI-powered MRI technology for cancer detection, or a new like super fancy, I don't know, smart speaker, the population who will suffer the most from climate change impact, generally in global south, will probably not benefit from these technologies either. And so I think one thing, maybe not the exact response to the question, but something related, is we have to think of this cost-benefit analysis at a local level, and be mindful that it will be hard to avoid this kind of historical dynamics. Right. So maybe if we start thinking about a very easy question, but maybe we go with this one. I think I'll just go around the room again. So can computing ever be completely sustainable? It's predictions. I don't know. Kirsty, do you want to go first?
Yeah, why not? I mean, probably not completely, but I think we can get a lot closer. One thing I'd really like to see is closing of the loop with waste. Because as Loic said, we ship a lot of the waste overseas. We don't reuse materials as well as we could do. And there's so much work on kind of circular economy and making sure that things are reused and recycled as much as possible. And if we could improve that, we could close that loop, I think we'd be a lot closer to being truly sustainable for computing.
Thanks. Laurent?
No, I definitely agree with what Kirsty just said. I think, I mean, it's easier to have it sustainable in the operation of, like, for instance, computing data centers, because then you use renewable energy, and in a sense, it's almost carbon free. But the big problem is waste generation and all the embodied impact. And if you can include indeed circularity, and that you don't need anymore to extract a lot of resources, but you actually reuse resources from other aspects or other facilities, then you're closer to something actually completely sustainable. very complicated. So I don't know if I hope we would see that in the next decade, but I'm really not sure.
Thanks. Raghav?
So I also think it could be possible, but I think the sustainability here, I would look at it from a slightly higher abstraction where we also have to balance it with the computing for sustainability. And I think there is going to be some cost which will never go away with all of the computing that we are doing. But if we can direct all of this compute to trying to kind of, mitigate and adapt to climate change or other challenges that we have, I think this directed focus, then that is where this cost benefit analysis might, strike some sort of a balance. And I think this requires a little more like a coordinated effort into like how we throw these expensive resources to what types of problems. And there are very important problems which we need to solve and address, and computing will be an important tool. So I think that would be my sort of take on this. Yeah.
Thanks. Jyoti?
Yeah, so yes, I do not think that computing will be absolutely, in the absolute sense, it would be completely sustainable, because for compute, we depend on natural resources like energy, water, minerals, land, manufacturing, and more. So even the most efficient systems still have material and environmental cost, that is the embodied cost embedded within them. So I think we cannot be completely sustainable. What my suggestion is that we should not think of a perfectly sustainable system, but we can start thinking of sustainability as not a binary state, whether a system is either not sustainable or fully sustainable. We can think about reducing the harm and improving the accountability over time, collectively, rather than individually.
Yeah, such important points. Thanks. I feel I've thrown hard questions on all of you. I should probably try to answer that one as well. It feels unfair otherwise. But I mean, broadly, I agree with what all of you said. And actually, so especially because we're talking about environmental sustainability here, that's what we tend to jump straight to when we talk sustainability. But as it was mentioned by a lot of you, sustainability is broader than that, and there is social sustainability. And actually, I think the only way we can achieve sustainability in any of these siloed meaning is by considering all of them together. We can't really achieve environmental sustainability, whatever that means, if we ignore social impact and if we ignore impact. That would, I'm like, it's going to be hard, but I think we need to make it even harder and looking at all these aspects of sustainability together if we want to have a shot at balancing any of them individually. That takes us to about an hour, and that's probably a good time to be close to wrapping up. Any points we didn't talk about? Any message you'd like to pass on, or have we covered all the hard stuff and the easy stuff as well? Yeah, Lauren?
No, I just quickly saw a question on the Slido about will sending data centers into space solve this? The answer is no, and we should absolutely not do that, because for our job in ground-based astronomy, we see so many already like satellites and going into orbit around the Earth, which is super crowded already. So sending data centers will absolutely not solve it. It will worsen it. So yes, that was just a clue.
Yeah, that's probably a good one. Jyoti?
Yeah, so I would say doing that would be an out of the world suggestion or solution. But I think that it will come with other costs, like Lauren mentioned, manufacturing, maintaining space materials and debris. Yeah, Kirsty.
Well, I think, and that's what was discussed. I remember Raghav in his introduction saying that he works with social scientists and other disciplines because this is not a problem we can sort hacking away. And I think the idea of data center in space is one that says, oh, we can find 100% technological solution to a problem that is technological, and that just doesn't work. I think we need to move past that. Kirsty?
Yeah, my point was a little bit similar. The fact that we have to be working interdisciplinary with this. We have to be exploiting the computing we have to solve environmental problems, as was previously mentioned. And we have to be getting experts in, like social scientists, who can really look at our behavior and look at where changes can happen, how people could be supported to make changes. It's a really big problem, but I think it's one we can tackle. But yeah, we need to make sure that we're listening to experts and listening to people, listening to different communities, and making sure that we're developing solutions that are acceptable to people and that are actually appropriate. So yeah, I like the framing of the different types of sustainability, because I think that's very important as well.
Well, you know what? I think that's actually a brilliant thing to leave it on. That sounds like, you know, we started with AI and we finish on people, and I quite like that. Thank you so much to all the panel for these inspiring discussions. I could have just stayed here and talked for another hour, but that's probably not very wise. Thanks to everyone for joining, and for the SCARES conference for organizing that, and Pete Millington for running the rocket science technology in the